Fig. If you only ever grow one fruit tree in a bucket, make it a fig. It may also be the oldest choice available to you. In 2006, archaeologists reported 9 carbonized figs from a Neolithic village in the lower Jordan Valley, 11,400 years old. The team proposed they came from trees grown deliberately, from planted branches. That would put the fig ahead of wheat and barley by about 1,000 years. Other researchers have pushed back, and the debate is open. But nobody disputes how those trees were propagated. From cuttings. Exactly how you start one today. So ask for Chicago Hardy, Brown Turkey, or Petite Negra. Chicago Hardy handles colder winters than most. Or take a cutting from somebody else's tree and pay nothing. Start around 10 inches and step up gradually. Too much medium too soon stays wet. Full sun, free draining mix. Year 1 it bushes out. From a rooted cutting you may see a light first crop. By year 2 or 3, a real harvest. A mature potted fig often fruits twice a year. Now here's what decides it. On many varieties, the tiny embryo figs form in autumn. They have to survive winter to ripen the following summer. Lose them to frost and you lose next year's crop, while the tree stands there looking perfectly healthy. So the pot moves somewhere frost-free before the cold arrives. That one move is the difference between figs and a handsome green plant. The fig was domesticated something like 5,000 years before the grape, the olive, or the date. It has been surviving human mistakes for a long time. Remember the fig like this, the one that fruits more when you restrict it. Next, the tree that has no choice about the pot. Lemon citrus is the one where a container isn't a compromise. If your winter drops below freezing, the pot is the only way you get fruit. In 1908, a used plant explorer named Frank Meyer found a small lemon growing beside doorways near Peking. He sent it home, and it carried his name. The University of California describes the tree as especially adapted for use potted or tubbed. That's a research collection saying the plant suits a container. So here's what to ask for, and the word matters. Improved Meyer. The original introductions were symptomless carriers of citrus tristeza virus. The tree looked fine, and quietly infected everything around it. Most Meyer lemons in America were destroyed to protect other citrus. A few clean trees survived. One was tested and released by the University of California in 1975 as the Improved Meyer. Every tree you can buy descends from it. Ask for Improved. If the label just says Meyer, ask again. Large pot, free draining, slightly acidic. Citrus roots rot fast in wet medium. And light. A south-facing window in winter is the minimum. A grafted plant usually flowers within a year or two, and fruits soon after. Here's what decides it. Never let it freeze. Citrus has no dormancy to fall back on, so it lives outdoors in summer and comes in before the first cold night. The difference between a citrus that summers outside and one kept in all year is not subtle. Meyer never saw any of this. He died in 1918 on the Yangtze River, and the USDA archives still list the circumstances as unexplained. Remember the lemon like this. The one that needs a window in winter. Next, the one where the pot doesn't just work, it beats your garden. Blueberry. Blueberry is a shrub, not a tree. I'm including it because for a lot of people the pot genuinely beats the ground. Before 1916, you could not buy a cultivated blueberry. Everyone came off a wild bush. Farmers who moved wild plants into gardens watched them die, and nobody knew why. A used botanist called Frederick Coville solved it in 1910. Most plants want a neutral pH near 7. Blueberries only thrive between about 4.5 and 4.8. He later called it the greatest discovery of his career. So ask for Top Hat or Sunshine Blue. Both are compact and widely sold for containers. Then fill the pot with an acidic, ericaceous mix. Not garden soil with something added. The right mix from the start. That's the whole argument for the container. In the ground you fight your soil for years and watch the pH drift back. In a pot you simply choose it. A nursery plant usually crops lightly in its first or second season. Here's what decides it. Water. Hard tap water is alkaline and will slowly undo the acid mix you paid for. Collect rainwater if you can. And feed with a fertilizer made for acid-loving plants. On pollination, even self-fertile varieties crop better with a second variety nearby. If you have room for 2 pots, take it. Coville didn't do it alone. Elizabeth Coleman White, read his 1910 bulletin, and offered her family's New Jersey land. She paid local people to comb the pine barrens for the best wild bushes. The cultivars were named after the finders. Their first commercial crop went to market in 1916, and every highbush blueberry in the world traces back to it. Remember the blueberry like this, the one where the pot fixes the soil for you. Kumquat. Kumquat is the citrus for people who think they can't grow citrus. It's the most cold-hardy of the lot. Where a lemon sulks, a kumquat carries on. And the whole fruit is edible, skin included. The peel is the sweet part, and the flesh is the sour part. The genus was named Fortunella, after Robert Fortune. He's the Scottish botanist the East India Company sent into China in disguise to steal tea plants. He brought the kumquat to Europe in the 1840s, alongside the tea that broke China's monopoly. Ask for nagami, the oval one, or mewa, which is rounder and sweeter. Give it a large pot with free-draining, slightly acidic mix, and all the light you can. Same as any citrus. It flowers in summer and holds fruit through winter. That makes it the ornamental of the citrus family, as well as the toughest. Here's what decides it. Feeding. Citrus in pots are hungry, and kumquats are heavy croppers. Use a citrus-specific fertilizer through the growing season. Yellowing leaves usually mean hunger rather than overwatering. It still won't survive a hard freeze. Cold hardy for citrus is not the same as hardy. Remember the kumquat like this, the one you eat whole. Next, the citrus that changed the Royal Navy. Limes are the smallest and often the most productive of the container citrus, and they carry one of the great cautionary tales in nutrition. The Royal Navy solved scurvy with lemon juice, and it worked. Then it switched to West Indian limes, grown in British colonies and cheaper. Limes carry less vitamin C than lemons. Scurvy came back on long voyages, and it took decades to work out why. The nickname limey stuck anyway. Ask for Persian lime, seedless and the most forgiving, or key lime for the aromatic one. Kaffir lime is grown for leaves, not fruit. Large pot, free-draining mix, maximum light. Limes are the most cold-sensitive citrus, so they come indoors earliest. A grafted plant fruits within a year or two, and limes often crop more than once a year. Here's what decides it. Humidity. Limes drop leaves in dry indoor air faster than any other citrus. A tray of pebbles and water under the pot helps. So does a room that isn't blasted by heating. Remember the lime like this, the one that needs the damp air. Now to the tree where everything I said about rootstock becomes real. Apples are where the rootstock lesson stops being theory. An apple's mature size is determined almost entirely by what it's grafted onto. In 1912, a research program began at East Malling, in Kent. Its first job was strange. Rootstocks were circulating under names like Paradise and Ducine, and nobody could agree which was which. Researchers gathered them from across Europe, sorted the duplicates, and numbered the survivors. Those M numbers are still on labels today, so ask for one of three. M27 is the most dwarfing. It needs permanent support, and extension sources note it isn't widely stocked. The best answer, and the hardest to buy. M9 is the workhorse, the most widely planted dwarf apple rootstock in the world, at roughly 40% of standard size. Brittle wood, so it needs a permanent stake. Bud 9 came out of the Soviet Union, bred for cold. Smaller than M9, resistant to collar rot. Ask about it if your winters are severe. A tree on a dwarfing rootstock typically fruits within 2 or 3 years. A standard tree takes 7 or 8. Here's what decides it. Pollination. Most apples need a compatible second variety flowering at the same time. A few are self-fertile. Ask which you're buying, because a lone apple on a balcony may never fruit. And here's the contrast that matters. M9 in a pot? Works. MM111 in a pot? Waste of a summer. One last thing about M9. It was never bred. It was found as a single seedling in the 1800s, and originally called Jean de Metz. East Malling collected and standardized it. It didn't create it. Most of the world's apples now grow on a chance seedling somebody noticed. Remember the apple like this, the one where the rootstock is the whole story. Next, the tree that was impossible in a small garden until recently. Cherries were, for a long time, the tree you couldn't have in a small garden. On traditional rootstocks, they make enormous trees. Two things changed that: dwarfing rootstocks and self-fertility. Until the 1960s, sweet cherries needed a partner. Then a breeding station in Summerland, British Columbia, released Stella, generally credited as the first self-fertile sweet cherry. Suddenly, one tree could crop alone. That single change is why a cherry in a pot is possible at all. So ask for two things together: a dwarfing rootstock, usually the Gisela series, and a self-fertile variety. Stella and its descendants are the ones to name. Large pot, full sun, consistent water. Cherries split in heavy rain after a dry spell, so steady moisture matters. A grafted tree on Gisela typically fruits within 3 years. Here's what decides it. Birds. A cherry in a pot is a cherry at eye level. Convenient for you. Extremely convenient for anything with wings. Netting isn't optional, and the pot makes it easy. On pollination, remember the split. Sour cherries are generally self-fertile. Many sweet varieties are not. Ask by variety, never by species. Remember the cherry like this, the one where sweet and sour follow different rules. Next, the one that flowers so early it needs rescuing. Plums. Plums, like apples and cherries, come down to what they're grafted onto. And Britain's most planted plum was an accident. Victoria was reportedly found in a garden in Sussex around 1840 and sold on by a nurseryman. Nobody bred it. Nobody planned it. It's self-fertile, heavy cropping, and nearly 2 centuries later it's still the plum most people grow. Ask for Pixie. That's the dwarfing rootstock, and it's what to specify if the tree is going in a container. More vigorous plum rootstocks make a perfectly good tree and defeat the purpose of a pot. Saint Julian A is excellent. It is not a container rootstock. Large pot, full sun, consistent water. Plums are hungrier than apples and appreciate a spring feed. On Pixie, a tree typically fruits within 3 years. Here's what decides it. Frost at flowering. Plums flower early, and a frost during bloom destroys the crop. But a potted tree can be moved, covered, or pushed against a wall for a few critical nights. Almost nobody mentions that. Portability isn't convenience. It's frost insurance during the 2 weeks that decide your harvest. Remember the plum like this, the one you can move away from a frost. Next, the tree that breaks the rule, I've spent 10 minutes explaining. Peach. Everything so far has been about rootstock. Peaches are the exception. There's a category called genetic dwarf peaches. They're not small because of what's underneath them. They're small because of the variety itself. The scion carries a mutation that shortens the internodes, the gaps between leaf joints. Same number of buds, a fraction of the space. That's a completely different biological mechanism from an apple on M27. Same outcome, different cause. So ask for a genetic dwarf. Bonanza and Pix Z are 2 names commonly sold, though check what your nursery actually stocks. Large pot, full sun, free draining mix. Peaches want heat, and they want air movement. Genetic dwarfs often fruit in their 1st or 2nd year, which is unusually fast for a stone fruit. Here's what decides it. Leaf curl. It's a fungal disease that disfigures the foliage. An infection arrives with rain on emerging leaves in early spring. A tree in the ground has no defense. A tree in a pot moves under shelter for those weeks, then comes back out. That's the whole trade with containers. You give up soil volume and you get control. Peaches are also mostly self-fertile, which makes them friendly to anyone with room for exactly 1 pot. I'm including this deliberately. It would be easy to say all small fruit trees are small for the same reason. They aren't. Remember the peach like this. The one that's small for a completely different reason. Next, the peach that isn't a different fruit. Nectarine. Here's something most people don't know. A nectarine is a peach. Not a relative, not a hybrid. The same species, separated by a single recessive gene that switches off the fuzz on the skin. The consequence is genuinely strange. A peach tree can spontaneously produce a nectarine, and a nectarine tree can produce a peach. It has been documented repeatedly, so everything from the last few minutes applies. Ask for a genetic dwarf nectarine. Same mechanism, same short internodes. Large pot, full sun, free draining mix, good air movement. Genetic dwarfs fruit fast, often within the first 2 years. Here's what decides it, and it's the same enemy as the peach, with one difference. Nectarines are more susceptible to leaf curl and brown rot than peaches. That smooth skin has no fuzz to shed water and spores, So the shelter routine matters more here, not less. Undercover from bud swell until the leaves have hardened off. Thin the fruit hard when it sets. A dwarf tree carries more than it can ripen. You get many small poor nectarines instead of a few good ones. Remember the nectarine like this. The peach with the gene switched off. Next, the tree grafted onto an entirely different fruit. Pears are naturally vigorous. On their own roots they make big, long-lived trees that take years to bear. So the dwarfing root for pears is unusual. You graft them onto quince. Quince is a different species in a different genus. A pear on quince is two distinct fruits joined at the union, and it's been done for centuries. Ask for a quince rootstock, and ask one more question with it. Not every pear variety is compatible. Some varieties won't form a good union directly. Nurseries solve it with an interstem, a compatible variety, grafted in as a bridge. Large pot, full sun, consistent water. Pears are less tolerant of drying out than apples. On quince, a tree typically fruits within 3 or 4 years. Here's what decides it. Picking too late. Pears must be picked before they're ripe. Left on the tree, they go soft and grainy from the inside out, while still looking perfect. Pick when the fruit tilts off the spur with a gentle lift, then ripen indoors for a few days. That timing is the whole skill with pears. Most pears also need a pollination partner, so check the variety. Remember the pear like this. The one grafted onto a different fruit entirely. Next, the earliest flowering tree on this list. Apricot. Apricots are the gamble of the stone fruits, and the container is how you fix the odds. The problem is timing. Apricots flower earlier than almost any other fruit tree, often in late winter, weeks before the last frost. In the ground, that's a coin toss every year. A cold night during bloom, and there's no crop, regardless of how well you've grown the tree. Ask for a dwarfing rootstock, usually one of the dwarfing plum types, and a self-fertile variety. Many apricots are self-fertile, which helps. Large pot, full sun, free-draining mix. Apricots hate wet feet more than most. A grafted tree typically fruits within 3 years. Here's what decides it, and you already know the answer. Move the pot. Bloom starts, a frost is forecast, and the tree goes against a wall or into a shed for the night. That's it. That single act converts apricots from a gamble into a crop. It isn't available to anyone growing in the ground. They also need good air movement to avoid fungal problems. So don't crowd the pot into a corner permanently. Remember the apricot like this, the one you rescue for one night a year. Next, the one built for the heat you're complaining about. Pomegranate. Pomegranate is a heat plant. Where others sulk through a brutal summer, this one is at home. It's also one of the oldest fruits in cultivation. Pomegranates were recovered from the Uluburun shipwreck, a Bronze Age trading vessel that sank off the Turkish coast around 1300 BC. The ship was carrying copper, glass, ivory, and pomegranates. Somebody was moving them as cargo, 3,500 years ago. Now a variety warning that catches people out. You'll see a compact pomegranate sold as Nana. Small, beautiful in flower, popular for pots. But Nana is generally grown as an ornamental, and reports on its fruit are not flattering. I couldn't verify that against a source I'd stake this on, so treat it as worth checking. If you want fruit rather than flowers, Wonderful is the variety most named for eating. Large pot, full sun, and heat. Pomegranates are forgiving about soil, and handle drought once established. They typically fruit within 2 or 3 years, and they're self-fertile. Here's what decides it. Watering rhythm. Pomegranate fruit splits when a dry spell is followed by heavy watering. The skin can't stretch fast enough. Steady moisture as the fruit swells is what prevents it. Cold is the limit. In colder zones, the pot comes into shelter for winter. Remember the pomegranate like this, the one that likes the heat you're complaining about. Next, a tree that can outlive everyone watching this. Olive. An olive in a bucket sounds like a decoration. It isn't. Olives are among the most drought-tolerant fruit trees, and drought tolerance translates directly into container tolerance. A plant built for thin, poor, dry soil will forgive a pot. And here's the thing most people never find out until they try. An olive straight off the tree is inedible. Not unpleasant. Genuinely inedible. From a compound called oleoropine. Every olive you've eaten was cured in brine or salt or water. over weeks. Ask for arbequina. It's compact, fruits young, and it's the variety named most often for containers. Now the honest part. Olive self-fertility varies by variety, and some described as self-fertile still crop heavier with a second tree nearby. I couldn't confirm the specifics for arbequina, so ask the nursery. Sun and sharp drainage, grit or perlite in the mix. Olives won't sit in wet medium. They're slow. Don't expect a crop in year 1 or 2, and possibly not year 3. Here's what decides it. Cold, and specifically the wrong kind. Olives need a cool period to set fruit, but they're damaged by hard freezes. In cold climates, the pot goes somewhere cold and sheltered, not warm. Remember the olive like this, the one you can't eat off the tree. Next, 3 bushes that belong here more than most trees do. Gooseberry. Gooseberries are a bush, and they suit a pot better than almost anything on this list. Shallow-rooted, compact, and productive in shade that would defeat a fruit tree. They also produced one of the strangest competitive sports in history. In 19th century Lancashire, mill workers formed gooseberry clubs and competed to grow the heaviest single berry. They guarded their bushes and fed them in secret. Some of those clubs still meet. The record berry weighs more than a small plum. Ask for Invicta or Hinenmaki Red. Both are widely sold, and both carry decent mildew resistance, which is the gooseberry's main weakness. A large pot and part shade is fine. This is one of the few fruits that genuinely tolerates a north-facing spot. A bush crops in its second year and reaches full production by year 4. Here's what decides it. Airflow. Gooseberries get mildew in still, humid air, so they're pruned to an open goblet shape, hollow in the middle, to let air move through. In a pot that's easy, because you can turn the container and stand it clear of walls. Remember the gooseberry like this, the one Victorian mill workers competed over. Next, the fruit America made illegal. Blackcurrant currants may be the highest value fruit on this list by weight. And for 55 years you couldn't legally grow them in America. In 1911, the federal government banned currants and gooseberries. They're an alternate host for white pine blister rust, a fungal disease that threatened the timber industry. The federal ban was lifted in 1966, but some states kept their own restrictions, and a few still have them. Check your state before you buy. That single piece of legislation is why generations of Americans have never tasted a fresh blackcurrant. Ask for Ben Sarek or Ben Conan. Both are compact, heavy cropping, and bred for smaller spaces. Large pot, sun or part shade, and consistent moisture. Currants are shallow-rooted and dislike drying out. A bush crops in its second year and peaks around year 4 or 5. Here's what decides it. Pruning to the right wood. Blackcurrants fruit best on young wood, so each winter, you cut roughly 1/3 of the oldest stems to the base. Get that wrong, and the bush becomes a thicket of old wood carrying almost nothing. Get it right, and it produces for 15 years. Remember the blackcurrant like this. The one the timber industry got banned. Next, the one you cut to the ground on purpose. Raspberries seem like the wrong plant for a container. They sucker, they spread, and in a garden they take over, which is exactly why the pot works. The container does the job that a root barrier does in the ground. But the variety type matters more here than anywhere else on this list. And the words are confusing. Summer fruiting raspberries carry fruit on last year's canes. So those canes have to survive winter, tied in and taking up space. Autumn fruiting ones, called primocane types, fruit on canes grown that same season. So you cut the entire plant to the ground every winter. Nothing to tie in, nothing to overwinter, nothing to cut off by mistake. For a pot, that's transformative. Ask for an autumn fruiting variety. Autumn Bliss and Polka are the ones most commonly sold. Large, deep pot, sun, and steady water. Raspberries are thirsty in fruit. You'll usually get a crop in the first autumn after planting, which is faster than anything else here. Here's what decides it. Cutting at the right time. Cut everything to the ground in late winter, before new growth starts. Cut in autumn, and you may remove canes that would still have fruited. Remember the raspberry like this, the one you cut to the ground every year. Next, the fruit you cannot buy at any price. Mulberry. You can't buy a good mulberry. Not because they're rare, but because they're impossible to sell. A ripe mulberry falls apart. It bruises if you look at it. It stains everything. Shelf life measured in hours. so it never entered commercial production, and most people have never tasted one. Growing it yourself isn't the cheap option. It's the only option. There's also a story about the wrong mulberry that shaped an industry. Silkworms eat white mulberry. Morus alba. In the early 1600s, James I tried to found an English silk industry, and thousands of mulberries were planted. The story goes that black mulberries were planted instead, which silkworms won't eat. The silk industry failed, the trees survived, and some of them are still standing. For a pot, ask for a dwarf or everbearing variety. Everbearing is the useful word, because it fruits over a long season rather than in one glut. One cultivar name commonly attached to dwarf mulberries seems to belong to a different fruit entirely. I couldn't resolve it, so check what you're actually buying. Large pot, sun, and not much else. Mulberries are self-fertile, tough, and productive young, often fruiting in their first or second year. Here's what decides it. Placement. The fruit drops, and it stains concrete, decking and clothing permanently. Put the pot where that doesn't matter, and pick daily in season. Remember the mulberry like this. The one you can't buy, only grow. Next, the tree that flowers when everything else is shutting down. Loquat. The loquat does everything backwards, and that's what makes it interesting. Almost every fruit tree flowers in spring and ripens in autumn. The loquat flowers in autumn, holds fruit through the cold, and ripens in spring. That means it's producing fruit at a time when nothing else is, and it's evergreen while it does it. It also means frost is the whole problem. The flowers and young fruit are exposed exactly when the weather is worst. Ask for a named fruiting variety, not a seedling. Seedlings take up to 8 years and the fruit is unpredictable. Grafted plants fruit in 2 or 3. Large pot, full sun, free draining mix. Loquats are tolerant about soil and reasonably drought-hardy once established. Here's what decides it. Winter shelter at flowering. The tree itself is hardier than people expect. The blossom is not. A frost during bloom removes the crop while leaving the plant untouched. So in a cold climate, the pot moves under cover for the flowering period, which is the whole advantage of growing it in one. Most loquats are at least partly self-fertile, though a second tree improves the set. Remember the loquat like this, the one that fruits in spring. And one last plant, which isn't a tree at all. Banana. A banana plant is not a tree, it's a giant herb. What looks like a trunk is a pseudostem of tightly rolled leaf sheaths. No wood in it. Cutting one is more like cutting a leek. That explains the whole life cycle. A pseudostem fruits once, then dies, replaced by a sucker from the base. You're not growing one plant for decades. You're growing a colony that replaces itself. And the variety to ask for was named in a greenhouse in Derbyshire. In 1830, a head gardener called Joseph Paxton received banana plants from Mauritius at Chatsworth House. He grew them in a heated pit, and in 1835, one flowered and fruited. He named it Musa Cavendishii, after his employer, the 6th Duke of Devonshire. Paxton went on to design the Crystal Palace. Almost every banana sold in the Western world descends from that plant, so ask for Dwarf Cavendish. Genuinely compact by banana standards, and the one grown most widely at small scale. Very large pot, heat, and a lot of water and feeding. Bananas are among the hungriest plants you can grow. Here's the honest position on fruit. Getting a banana to crop in a container is demanding. Heat, a long season, constant feeding. In a cool climate without glass, you may get a spectacular plant, and no bananas. I couldn't find a good source confirming reliable container fruiting in cold climates. I'd rather say that than sell you a harvest. So the fair version. In a warm climate or under glass, Dwarf Cavendish in a large container is a realistic fruit plant. Outdoors somewhere cold, treat it as dramatic foliage that might surprise you. Remember the banana like this, the one that isn't a tree. That's 20. Now the part that keeps them alive. Keeping them alive, everything from here applies to all 20, so I'm saying it once. Start with the mix. Fruit trees in pots want a free draining medium with structure that lasts. A quality potting compost. Roughly a third by volume of grit or perlite. Something to hold moisture without going soggy. Do not use garden soil. It compacts, it drains badly, and it brings weeds and disease. Blueberries are the exception, and get an ericaceous mix. Feeding. A container tree has only the nutrients you give it, and watering washes them out through the drainage holes. A slow-release fertilizer in spring. Then a liquid feed every couple of weeks through the growing season. Switch to a high potash feed once fruit sets. Stop feeding deciduous trees by late summer. Late nitrogen pushes soft growth that won't harden before frost. Watering. This is where most container trees die, and both directions kill. Check by weight. Lift the pot. A well-watered pot is heavy, and a dry one is noticeably light. After a few weeks, you'll know instantly, and you'll stop guessing. In peak summer, a fruiting tree in a pot may need water daily. In winter, once a fortnight. There is no schedule. There's only the pot. Pests. Mostly aphids, red spider mite in dry conditions, and fungal problems in still air. Space the pots so air moves between them. That habit prevents more disease than any spray. Now the part nobody selling you a tree explains. Buying a tree that fits a pot is not the same as keeping it productive there for a decade. Left alone, a container tree declines. Roots reach the pot wall and turn. They circle, and over a few years, they build a dense mat around the inside. That mat replaces growing medium. Water holding drops, so the tree dries out faster. Nutrients deplete. Drainage worsens. Growth stalls. Fruit gets smaller. Leaves yellow earlier each year. The usual response is more water and more feed, which doesn't fix a volume problem. The fix is to prune the roots. It sounds brutal, and isn't. It's how bonsai trees live for centuries in shallow trays, and how a fig stays in one pot for decades. Do it in dormancy, late winter for most deciduous fruit. Lift the tree out. You'll see the circling clearly. Trim the outer roots away and tease out what's left. Then refresh the medium and put the tree back in the same container. You aren't potting up forever. You're resetting the pot so the tree can stay in it. How often depends on species and vigor. The tree tells you. When it dries out unusually fast. When growth slows for no reason. When roots show through the drainage holes. Prune the top proportionately at the same time. A reduced root system can't support a full canopy. That one practice separates a tree that gives you 3 good years from one that gives you 20. Before you buy now, before I summarize, a quick check. Don't scroll. Answer these in your head. What's the first question you ask the nursery? It's rootstock. What's the cold rule? Pot equals 2 zones colder. Always. What keeps a tree alive past year 5? Root pruning. Got all 3? You already know more than most people buying a fruit tree this weekend. So here are the 4 questions. Screenshot this, or write them down. 1. What rootstock? 2. Self-fertile. 3. Chill hours match. 4. Permanent staking needed. That's it. 4 questions. Everything else is detail. Any nursery that can answer all 4 is worth buying from. Any nursery that can't, isn't. One extra note on question 3, because I skipped past it. Chill hours are the winter cold a variety needs to break dormancy properly. Too little and the tree leafs out unevenly, and barely fruits. Too little for the variety, and it blooms early and loses the crop to frost. Your local extension service publishes the average chill hours for your area. That's the single most useful number a fruit grower can know. Find it once, then match every variety you buy against it. Closing dame. So let's go back to where we started. You were told fruit needs land. It doesn't. And the proof is in every commercial orchard on Earth. The technology behind a small tree was standardized in Kent in 1912. Researchers gathered the rootstocks already circulating under confusing old names, sorted them out, and numbered them. Those numbers are still on labels. The whole industry adopted them, because small trees fruit sooner and yield more. Nobody hid any of this. It just never made it onto the label at the garden center, where you were sold a standard tree and told you needed an orchard. And now you have the 4 questions. What rootstock? Self-fertile? Chill hours match? Permanent staking? Those 4, a pot on the ground, and roots pruned every few years. That's the whole thing. And if you remember nothing else from 40 minutes, remember this. Pot equals 2 zones colder. Always. Subscribe if you want the mechanism, not the list. Tell me in the comments what you're growing in a container and what zone you're in. And watch every vegetable you plant once that seed companies hope you never find next. Same principle, different obstacle. That one is growing food without soil. This one was growing food without land. I'll see you there.